So here what I'm doing is nulling out my system. I guess that's the best way to look at it. And what I have set up here is I have a function generator that feeds a matrix. The matrix feeds some I/O. So this is from the matrix, output balanced. Okay, so these patch panels are fantastic things, and what I can do is I can flip it over to a calibration mode, and what it does is now they're out of phase with one another, and here I can measure, okay, so this one is 1.54 compared to this one, which is 1.527. So I could take this pad and I could knock it up a little bit. It doesn't have a very fine detailed trim. 173. I got 173 now. I got 156. You see, you can tweak it. And then so this is the output, 1.3 and then 1.3. Then I'm getting back as a return 1.5 and 1.567. And I can measure it over a period of time. So what I have is I created these little boxes here, and if you click them, so this was my software engineering. So if you click them, they reset. And what it does is it displays a big number for you. And after, I think it's 100 measurements, it's now, okay, well, now it takes, it's 25. I got it set to 25 right now. It takes like a whole bunch of readings, and then it measures it over time. So I've confirmed that these two channels are matched up, and then when I have a device under test, what I do is I route to it. Okay, so here I'm going to stop the test, and here what I do is right now I'm bypassing my bus. Okay, so right now it's coming right from the signal generator transformer, and instead of it going to this bus, it bypasses the bus and it just goes directly to where this bus would connect on a different module. And here what I'm doing is I'm routing it back to the input. And I got this labeled wrong. It should be 353 out. Right? So it goes out of the oscillator into this. And that's how it reconnects from one to the other. So I can take that out of bypass, put this into circuit. Now on the back of my device under test, that's this bus. So anything that goes to this bus goes to my device under test. So here I have a piece of gear on the bench. I can take the transformer out and I can feed my computer, or I can feed music. I don't have that set up, but you can hear it doing stuff up there. I can feed it to my speakers, right? So if I have my speakers, then I have a Pod 22 loudness meter there. So I can monitor on that. Okay, so now what I want to do is I want to enable my sweep. Check this out. Okay, so I'm gonna clear everything, and that clears my spectrum sweep. So now what it's doing is it's going to each one of these, and it's saying a bunch of commands. Okay, which commands am I telling it to do? Okay, so I'm saying to him, well, let's stop this. It's going real quick. Okay, so channel 1 goes to this time scale. So every time the frequency changes, I'm also focusing these oscilloscopes to make sure that they're capturing the proper, width of the frequency that I'm looking at. So here I'm looking at 377 hertz, and then I ask the here, let me zoom in on that. So here what I say is, okay, well, signal generator, be this frequency, and then I say, signal generator, what frequency are you? And then it asks, and it gets the number back, right? So here it reads that data. So it says signal generator listen, and every time it says, well, every time you say something, it listens over here, and it says, okay, well, you're that frequency. So someplace in this list it'll be, the whatever the frequency, there it is, right there. So 377. E to the 2 moves the 2 decimal points. And then it listens back. So it tells the scope, okay, so then it says to the scope, okay, well, change your time scale to this, measure volts RMS, and then it says, hey, adjust your time scale again. So this is a bug. Measure your VRMS. So it's measuring it twice. And then it goes to channel 2. Measure volt peak to peak. Measure VRMS. Change the time scale. This could be cleaned up. So to make this more efficient, this can be said to both of these devices one time, 1, 2. So I could eliminate 2 of these. Yeah, maybe, actually, no, yeah, I could eliminate 2 of these in this call just to make it move a little faster. Okay, so let's run this test. So I'm gonna have it up on my other monitor. So run the test. Okay, so now what it's doing, so it's taking between 50 and 250K. Look how bad. I gotta work on my software interface. So between 50 and 25K, here is what the readings are. So it compares left to right. So this is channel 3 and 4. So 3 is orange and 4 is yellow, of course. Anthony, your software computer resistor code guy. So the brown one is 1, 2, 3, 4. And that's what's coming back through this system. Okay, so now if I kill this bypass, yeah, so now I don't have any signal going through. So now it should so now if I reset this, all of this wait, hold on. Let's pull it out. Oh, because I'm on calibration mode, of course. Okay, so now if I go to out, bypass, now it shows up on the pod 2s. So if I turned on my monitor, if I was brave enough, it would be just tones. Okay, so now what I'm gonna do is I'm gonna reset my chart here. I go poof. Okay, so now I got a new chart, and what it does is it sends a tone out at each one of those points and measures VRMS. But what it's also doing is it's saying, okay, focus, change frequency, focus, change frequency, focus, and it's adjusting the ups and downs. In this case, it's just adjusting horizontally, but when you have a reading that is invalid someplace else here, or out of range, or it's the wrong voltage, there's my frequency sweep. What it does is it adjusts the amplitude accordingly. And what'll happen here in this frequency sweep is you'll see it's an offset. So what I do is I capture like one, I never capture the same frequency twice. And then it'll do an offset, and it'll jump back and forth, and this will sweep infinite amount of times, just to get whatever the current running configuration of the filter is, or whatever it is that I'm repairing. This software is, I think I'm gonna make it free or something. Like it's just like, who else has this stuff? Like, it's, of course, if you want it, I'll show it to you. But so these are all Visual Basic utilities. All these routing things are all Visual Basic utilities. There's 2 kinds of routers in this. So this is a balanced line level, and then this is all coaxial. So all the coaxial stuff goes here. But then there's also, if I launch my spectrum analyzer, does it launch? Oh boy, let's see if it's in the middle of doing a whole bunch of, I'm gonna stop my test. As soon as I stop my test, it's a big button, I know. Come on, stop test. All right, there's the spectrum analyzer. So it's actually bigger than that, right? So it measures a whole bunch of other stuff, and it measures zoomed in. So if you have your spectrogram, it does a zoomed in version if you wish. These scopes, I have it set up. Do I have it set up? I think I did. If you push this, here, come on, stop test. All right, so if you push FFT, does it work? Oh yeah, it does. So now if I run the test, what it'll do is it'll overlay the FFT of the sweep. But I think what it does, so this is where it gets, the FFT is based on this spacing, so you have to not do the auto adjust. Anyway, software, once you get into it, it becomes gargantuan to manage all of these things. But all of these things are based on AES-70, and they're all running on, you know, the same remote procedure calls as all things AES-70. You know, just for fun.